There we are. Hello and welcome to DeWitt3D Canada on this wonderful Sunday evening. Hey, listen, there's people here already. Like, I can't believe it. And Jose Ferreira, yes, #1 to hit like. Thank you so much, sir. And who else is here? We have Delmar Franks, third to like. So there was some unknown that hit it second. HVAC A to Z, Sergio, hello, sir. And Non-Fam is here. And I see Brendan Wilson, Nick. Let's see, keep going down the line. Stream Elements is here. Hello, Stream Elements. You be nice. Nightbot, be nice to people tonight. Come on. Don't want to have to ban you again. And then we have Jeff Thorson, Shot L3D, 3D Medic Vince, and Smalls. Hello. And Guy the Jedi. Hi, Guy the Jedi. That's poetry in motion right there, guys. Listen, I need to do one thing real quick here. Oh, it's already done. Don't worry, it's already done. Okay, so listen, anybody, bye. Oh, see you, Shadell. Bye. Oh, you're saying hi, Guy the Jedi, bye. Okay, you were continuing my little poetry session there. That's good. That's good. So anyways, guys, tonight, we are going to do some tuning on this thing. I tried to do a few things in advance of the stream, but it's been a busy weekend. I wanted to get a before print done, which I didn't, but I kind of have 2 before cubes. So we can compare cubes once we do some tuning tonight. We can print another cube and find out just what difference it might have made. Although these are both pretty damn good looking cubes for an untuned first prints off the printer. So there we go. Who else is here? 16 watching, and how many likes? I got to check the likes because I can't, only 11 likes. So I'm going to give myself a like to make it 12. But as soon as the likes equal the viewers, although that's not, oh, now it jumped up to 15. I like that because there could be some thumbs down too. So, which I don't see that. So I can't really do the math and add them in. So anyways, to get right at it, hopefully I don't have an echo tonight. I see a whole bunch of sound meters going, but it only should be the one. This guy here, hello, test, tap, tap. This should be the only mic working. So, oh, that's you, the thumbs down, Jeff Thorson? Okay, that's fine. Hey, listen, YouTube doesn't care. They just measure clicks. They don't measure whether it's a thumbs up or a thumbs down. This camera looks a bit dark to me right now, but I could always switch over to this guy here, and I can always talk onto this camera here. So either or. So what we're going to do first, I printed a spool holder and a filament guide just to get on this so that when we do put the test print on, we can actually have filament running off of a filament holder. Dwayne King, hello. You haven't put in the like yet. Okay, that's okay. That's you that hasn't put in the like. I get it. I hit what you mean. I get what you mean. We'll get to it. Come on, let's see. There we go. 17. We can live with that. 15 people watching, 17 likes. 2 people have dropped out already. I don't know if that's a good thing, a bad thing. Anyways, we'll see. So I'm going to, as you know, we've done test prints on this. We've done the extruder calibration as far as the E-steps go. We did that last week. Oh, I was going to say, why is my bed? My bed's a bit warm. I was heating the bed up a little bit earlier so that I could have it sort of preheated because I'm cold in here too. That's why I got the jacket on. So anyways, so we've done the extruder calibration as far as the E-step calibration goes with the extruder. We know we're pushing 100 millimeters of filament through. When we ask for 100 millimeters, we got the clicky probe all working, so we're able to do the bed leveling, the mesh leveling, the Z calibration, so we get a perfect first layer every time. So basically, the next steps and the guide I plan to follow is the Ellis print tuning guide, which is, if I can switch to my display right there, so it's the Ellis print tuning guide, which we're going to follow. But prior to doing that, I want to do the resonance testing. So in other words, input shaper. So we're going to follow this Clipper documentation for measuring resonances. So the the kit that we get. Oops, why did I do that? I meant to do that. I meant to do this right here. So the kit that we get from LDO comes with an input shaper toolkit. Okay, that's the LDO input shaper toolkit. Now the nice thing about that, if you look at the instructions that they give you on the, I don't know why that, every time I switch windows, that button comes up. So forgive that. I'm going to have to disable that somehow. Anyways, although subscribe if you're not, because hey, so here we go. So what they're explaining here is they talk about wiring up your ADXL to your Raspberry Pi, et cetera, et cetera. Well, the nice thing, we can skip right by all this, and we can come right down to the part that says measuring resonances to a point. There's one thing I have to do here first, which is, oh, where did I find it? I have to actually go into the Raspberry Pi, and I have to input some information so it knows that I have an accelerometer on here. Oh, and that starts right up here with the software installation. So that's kind of the part where we're going to start at. The nice thing about the LDO Input Shaper Toolkit is the wiring. I don't have to do any wiring. So they have it comes with an ADXL 345 accelerometer. It's different than the ones I've seen before. Well, this is the same one that was on the 2.4. It's got a ribbon cable that goes into it as opposed to me having to wire it up. So it's got a ribbon cable that goes from this into a piece that is on the Raspberry Pi. And I think I put the piece on it already because I can't find it. So I'm pretty sure I already put that on the Raspberry Pi during the build. And then we have this little piece that we printed that is the mount, which mounts the ADXL 345 onto the hot end, onto the stealth burner. So we're going to work on that. Hey, old curmudgeon, lurking for a bit. That is cool. We like our lurkers. We like our workers. We like our... I'm not going to go there. Anyway, so what we're going to do first is follow the instructions through here. So if I go back to this... Why are you doing that? Something with... No, if I click this button here, it does that. Something to do with OBS. That should only come up when I click the button. I don't want you guys to think that I'm overly asking you to subscribe, but sorry about that. We'll fix that. Just a little technical glitch. Welcome to live streaming, right? So what we're going to do is go into the Raspberry Pi, and we have to basically tell the Raspberry Pi that we have an ADXL 345 that we're going to hook up. So it's been a while since I've done this, and I think I did it a little differently on the 2.4, but we're going to go through this way and see what happens. Let's give it a shot. So first thing I'm going to do is I'm going to SSH into the Pi by opening a terminal window or command prompt. Terminal window, command prompt, call it what we will. So we will SSH Pi at 10.0.0.178. What's the password? And we are in the Raspberry Pi. Now, the first line we wanted to do was the sudo apt update. So we're going to just click this button here to copy. And I always forget how to paste into the terminal window, but I believe it is Control-Shift-V. Nope, maybe it's just Control-V. Nope. Maybe it's just Shift-V. Nope. Oh, Alt-V, Alt-Control-V. Oh, how do I, or do I just do an up arrow? No, I don't do an up arrow either. I don't remember. How do I, oh, right click. Oh, right click. Oh, there we go. There we go. Thanks, Delmar. Did I get the wireless issue shorted? I hope so, Smalls. I hope so. Okay, there we go. So we're doing our update here. I hope the wireless issue is working. I've been playing with this thing pretty much all morning, and I haven't had a problem with it. Why is... oh, wrong screen. Just I want to keep it back on the display. Okay, so now we're finished that portion of it. Now the next thing we need to do is Clippy is switch to this directory in order to install NumPy in the Clipper environment. So we're going to copy that. And now that I know, we right mouse click right here. And here we go. And we're done that. And okay, depending on the performance of the CPU, it may take 20 minutes. No, it goes pretty quick. Afterwards, follow the instructions on the RPI microcontroller document, set up the Linux MCU. That's fine. Configure the ADXL with Raspberry Pi. So we want to run these commands here. I've done this a couple different ways. Oh, commands not found. Okay, maybe I don't need those. Maybe I don't need those. That was fast, and that's kind of what made me suspect, did it work? Let me run it again. It can't hurt to run something twice. It didn't come up with an error or anything. Oh, hang on. Non-user install, create a temporary directory, required already satisfied. Oh, it's maybe because it's already there. Remove build tracker. It was probably already there. But my question is, why did this? Oh, maybe ADXL 345, configure MPU 6000, 9000 series. No. With Pico. It is an ADXL 345. But then, or did I clip the wrong one? Let me just try that again. Okay. Command not found, command not found, command not found, blah, 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 blah. So I love this stuff lied. That needs to go to printer config. Oh. Okay, so that's not in here. This is my printer config. Oh, if I would read, I would right there, add to the printer config file. Oh my goodness, you guys, see? Helps if I read stuff. So let's go ahead and add that to the printer config file. I have a very, very bad habit of not reading stuff that I should be reading. Let me, I'm not a fan of a blank screen up there, so I'm just going to go like this. And I'm going to put this like that. There we go. At least you know just so you know I'm still here and alive. Okay, printer config, and we can add that. I'll just add that at the bottom before I get to the macros, just so I know where it is. I believe this is where I added it on the 2.4. My displays, and then there's my macros. I'm going to throw that in at the bottom of the config file before the macros. There we are right there. Let's see, RPI, accelerate ADXL 345. We should be good there. So if I save and restart, there shouldn't be any errors. Oh, I wonder if I need to, if there's something going on with my MCU. Hey, Zixelter, how are you? Cliff Douglas. I know I didn't say hi, but thank you for that tip. Yeah, I think we're good. And Jose, yes. Okay. So something in here. Let's see. Something I just put in there. Should have put it at the top now so I don't have to scroll all the way down to find it, but that's okay. It doesn't matter. Easy enough. So, oh, it's probably got, no, the serial. I think I have to copy the serial, although it's referring to the Clipper host MCU. But do I have to duplicate the serial from up here for that? Oh, there we go. That restarting thing again. That's weird. Okay, or do I have to duplicate this down in the serial section of the ADXL? Right down here. Okay, Jose, thanks for popping in. I appreciate that. Always appreciate it. Did I enable SPI for RPI? Oh, did I enable SPI for RPI? Oh, boy, that's a good question. This is why you guys are here to help me out in this part of in this portion of the install, because I kind of get lost when it comes to that. Was that one of the, let's just see here, bear with me. I don't know if I did. Unless I missed a section. No, I don't think. Huh. Check and follow the instructions to set up the Linux MCU on the Raspberry Pi. Oh, okay, right in here is where I need to go here. Okay, so this is where I've got to go right here. Okay. Okay, I missed this section. Yeah, this is the section I missed. Okay, let's go in here and do this. Okay, let's see. Is this still an active session? Yes, it is. Good. And then we need to go in here. So we've done that. And then we're going to compile Clipper microcontroller code. We'll copy this. Okay, and now this is where I got to really follow instructions closely. Set microcontroller architecture to Linux process, save and exit. Okay. Microcontroller architecture. We go down, enter, Linux process, enter, and then quit prompts for save. So Q and yes. Okay, we've saved that. People zeroing and cutting the place blocks. Yeah, and that's exactly what I do. Zen, exactly what I did. Okay, so we've done that. Okay, to build and install a new microcontroller code, run this. So we have to run this code here. Okay. Here we go. So far, good. I have a bad habit of skipping through instructions, and I got to get out of that. If ClickBLR reports permission denied, which it didn't, so we don't have to worry about that, then you need to add your user TTY group. The following command will add pi to the TTY. So we did not get a permission denied error. Everything went fine there, so we don't have to do that. Remaining configures complete the installation by configuring Clipper secondary MCU following the instructions in Raspberry Pi config and multi-MCU sample config. And I believe that was I think we've already done this stage. Or have we? No, I don't want this. This is multi-MCU config. I'm just reading this and figuring out if I have to do this. The RPI controller uses secondary. Typically, both X and Y axis are controlled by the microcontroller. Oh, we've already done this. Okay, we've already got this part in there as a temporary clipper host MCU, except we're having a Raspberry Pi host. So I think that's what I needed to do. Let's just have a look and see. Let's see what happens here. Yeah, I think we're all good. Yeah, I think that did it. Yeah, so we had already done that stage. So I'm going to go back and go back. And then we can come down to here. So now, yeah, I think we're good. We did not get the error. So I think everything is configured fine in here. So I'm guessing what we need to do now is go ahead and mount the accelerometer. I want to make sure that I put the other piece on the Pi. I honestly don't remember putting the other piece on the Raspberry Pi, but I must have. So we're going to switch over to this guy. Oh, why is that? Let me see if I can shut that off. May not be bothering anybody else, but it annoys me that that keeps popping up every time I, oh, I know why. If I just click on that, and that should be fine. Okay, so let's turn this over. Well, first of all, let's power it off. If I'm looking on the bottom, let's unplug it. Let's have a look and see if I did. And I did. So the yeah, it's part of the, yeah. So what I did, it's right here. If I zoom in on this a little bit here, you can kind of see that, you can see the white casing right there. So this part is where the Raspberry Pi is going to plug in right to here. And it's part of the board that is used for the power to power the Pi. So yeah, it's all part of this board that we put on for powering the Pi. And so the accelerometer is going to go right into here. So I can actually, I can plug that cable in now. It's deceiving because it looks like a really short cable, but when you unspool this, it's a long cable. It's actually almost too long. And what I ended up doing in the 2.4 is I just left it plugged in here and I just tucked it back in here. And when I use it, I just pop it out through the front, hook it onto the ADXL 345. But I mean, that's a long cable. The only thing I don't remember, let me pull that black pin out to get it ready to put in, or does that lift up? Well, it lifts up. I just don't remember which way. I believe, and I mixed this up last time, I believe the wires come towards me in it. Yeah, I believe they go in towards me, or would they go in down? Well, you know, there's only one way to find out. Actually, come to think of it, the blue faces me. I am pretty sure that that is the way that goes. So we'll lock that in there. So that's locked in. We're just going to kind of pull this through the front grill here, or the side front grill. Yeah, we'll pull it. We'll just pull it up through the front grill for now. I'll figure out how to kind of do this a little more stealthy looking down the road. But for now, we'll just do that. We'll tip this back up. There we go. Because this just really has to reach up to the hot end is all it's got to do. So it'd be almost nice to have a retracting. So if I pull, I go clink, clink, and it retracts right back in. Golden Jaguar, hello, sir. How are you, my friend? Nice to see you here. Correct, blew out. Yeah, I'm kind of getting memories from when I did the 2.4. So what we're going to do here is just grab these little. This comes with. I don't think I need screws that long. So on the back of the hot end, on the back of the stealth burner, right. If I move this up a bit. So on the back of the stealth burner, you can see where That's what these two heat insets rate. Oh, my hand's got to come in the other side, but you can see two heat insets, one right in front of my finger and one there. And then back there is where we mount the accelerometer on this guy, on the back of the stealth burner. Goo sound effects. Oh, you like the sound effects? What like was it? Oh, I don't know what the sound effects were. anyways, that's okay. So they give you some screws here with the little kit. I don't know why they've given me such long, like these are like M40s, M340s, and a couple M3. These look like 25s. I find those are all too long, but anyways, that's okay. So what we need to do here is we're going to mount the accelerometer. Now you got to make sure based on the accelerometer you're getting, because there's several different pieces you can print for mounting onto the back of your print head. But this is going to basically mount on that way, and the accelerometer is going to come out to the side like so. Cable retracting. Yes, that would be. The yeah. I try to make the stream as exciting and sound effective as possible. So, yeah, I think that's going to go on this way. So basically, we've got two little holes on the top of this. We have our accelerometer, and the two little holes on the top of the accelerometer are going to match those two holes, and it's going to screw in with these little self-tapping M2s, I believe. So I got to grab my 1.5 millimeter hex key to do this. Itchy nose. Okay. I lost. It's a shame. I had a nice hex key with a handle on it with a 1.5 millimeter, but it broke because it's so skinny and thin. I'm going to actually start this with my fingers. We hear thumping on the floor. We're dog sitting a puppy for probably another week, hopefully no longer. And he's just he is a whiny dog, whiny dog. Does not like to be alone. Does not. Anyways, it's okay. He's just a pup. Okay, so we're going to screw this in here. Like so. And like so. Screws pop through a little bit, not a big deal. And now this piece is just going to go, we're going to use two M3 bolts through these holes into those heat insets that I showed you on here. So basically, we're going to come over here. That stupid thing. Anyways. Yeah, you can kind of see them right up here if you look through where my fingers through the hole there. It's going to mount right in the back here. So, but I believe these are going to be, well, maybe these aren't too long. Oh yeah, these are going to be way too long. If you look how far these things are sticking out there. I don't need anything nearly that long. So we're going to throw these all aside. And that's part of their kit, which anyways, that's okay. So we're going to open our little handy dandy toolbox here and find some decent size M3s for this. So let's see. I think, what do we have here? M3 12s. 12s will be perfect for that. Let's have a look. Yeah, the 12s will be perfect. We're sticking out. That's how much we're going to get bitten into the heat insets. So those are perfect. Good guess. And those I can use my 2.5 millimeter wrench on. So, except when I dropped both of them. Can you believe I dropped both of them? Okay, Take two. Okay, so we're going to grab some bolts out. I'm going to guess M312. And we're not going to drop them this time. I really hate gravity. Okay. Let's pull this over some. Okay, we'll get up in here. I know it's hard to see what I'm doing up here. You can kind of maybe sneak through here. I was going to say, I didn't just drop it again. So this guy's going to come in the back behind here. Oh, Lord, I'm just laughing at myself. If you can't laugh at yourself, who can you laugh at? Okay. And into there. Do not cross thread on me. There we go. That's better. Okay, and then we'll grab our other one. So you can see it right through here. That's kind of where that's going to live. And then every time you know, if you change surfaces, if you move it onto a different table, move it to a different location, you're going to want to run a resonance test on it. That one's in, and that one's in. There we go. So it's nice. Whoa. Nice new home right in there. You can just see it right there. And again, I believe it is, when I go to put the cable in, it's going to be the blue cable facing the back. So there we go. So now we will plug this in, and we will then we'll power on the printer, and we'll make sure that Clipper recognizes that it's on there. So we'll pop that black, clip forward. Oh, come on. Or is this one different? Oh, this one pulls out. Okay, the one on the Raspberry Pi, it's a little clip that flips like a hinge, and then you tighten it. This one here just actually pulls straight out. I'm positive it's blue to the back, but let's make sure. Huh. It might just be, yeah, I think it's blue to the back. It'll either work or it won't. And then we'll pop the cable in and tighten it up. Okay, so we have the cable in. Lots of spare cable. Let's plug it back in and power it up. Okay, here we go. You can see it booting up on the nice, beautiful color rainbow display. Mr. Zen, do you like the yellow display? Yeah. Never let that down, you know. Okay. Then what we're going to do when this is booted up, we're going to query the accelerometer. Number one, make sure it's there. First and foremost, and second and third most. Oh, you know what, guys? See what I would have made? I made one of these little guys. I made a little... I've had a few of them, but I've never made one yet. It's a little steppy from an LDO steppy, little keychain of a stepper motor. It's cute, cute. They send one with every. They send a kit with every printer. Okay, let's boot it up here. So now, what we want to do is in here, we want an accelerometer query. So I'm going to copy that. I'm going to paste that in here, and we're going to enter, and it's going to do nothing. That could mean either I've got something configured wrong, or I have the cable in backwards on the hot end. My guess would be that I have the cable in backwards on the hot end because nothing's coming back. So I'm going to pop the cable off. That's my guess. Usually you have to run it twice. Oh, really? Well, let's try that first. So So let's do this, up arrow, and run it again. And nothing. No, it's not even throwing an error. So I'll try the cable. So we're going to try and switch the cable. And of course, every time I do this, I get it wrong. So we'll put the cable blue side forward and pop it in. There we go. Okay, and let's see what happens now. Switch over. We'll run it. Oh, why am I getting bed mesh, Cal? What the heck? I just did accelerometer query. There we go. So now, it was a cable in backwards. So basically it is saying, yes, I see the accelerometer. Here's my values right now. Those values mean nothing to me. You guys may know what they mean, but I have no clue what they mean, and I don't think I need to have a clue what they mean. All that tells me, though, that's telling me, yes, I recognize you have an accelerometer on. Okay, and then from there, I can go to the measuring. I can do an accelerometer query, which we've already done. There's one more thing to do. Measure axis noise. That's the one here. So we want to measure the axis noise, which basically says, is there any movement right now? Or it's going to measure the existing or current vibration, I guess. We do that, and it's going to come back with something, usually. There we go. And then it gives you, back here, it tells you that should be somewhere in the range of approximately 1 to 100. Too high, so 1,000 and more, can be indicative of a sensor issues, problems with its power, too noisy, imbalanced fans on a 3D printer, etc. But I'm coming back right now with a reading of 8.9, 10.4, 20.9. We're within those ranges. Collie 5, you got your 2.4 up and printing. Awesome. Good stuff. No, I think, Neil, I think we're good. I think we're working. So let's try it and see if it's going to work. Because we're getting readings back from it. So let's go ahead now. Now what they're saying is measuring resonances. So we want to test resonances axis X, and we're going to run that. So we can copy that, and then we're going to test resonance axis Y. Now there is a command to do it both at the same time, and I don't remember, unless it's just test resonances, which I believe it's if I just go test resonances and don't put an axis in, it'll do both. So let's go ahead and try that. No, it's missing axis. It needs the axis. So axis X, unless I can go X and then space Y. No. Or if I just go X, Y. I know there's a way to do them both at the same time. Let's just do X to begin with. Now, oh, maybe SPI on pi. Now, maybe I am missing that. It's not doing anything. It is not, maybe because I haven't homed anything. See, nothing's, okay. Something is not. I'm going to do a restart. I'm going to reboot. See, it restarted itself. What the heck? It's doing this stupid thing again, where it's almost like it's losing connection. I'm going to reboot. I'm going to reboot and just give it a fresh reboot. I've got to figure out why it's doing that drop connection, get gain connection again. When I print a file, I can print fine. It's when I'm working and doing stuff like this that it seems to do this. And I don't know. I really don't know. I'm sure it's nothing to do with my Wi-Fi. The Wi-Fi is working good. The stream's not being interrupted, right? So if I was having a Wi-Fi issue, oh, Shaper Calibrate. I think that's the one, Neil. Yes, I believe you're correct. I know there is a command, and that's probably it, that does it both at the same time. And I don't have to read the chart. I just go by what it suggests. It's what I did with my 2.4, and it worked perfectly fine. So let's get this rebooted. Okay, we are rebooted. Okay, let's see if we are. No, we're getting an error. MCU is it shut down? Oh, okay. Here we go. Okay, we're up. Let's see if I can make sure I can home. There we go. Now we're moving. We're just going to home this first. Keep these things. Oh, I'm vibrating on something on my desktop here. Just keep this up out of the way while we home. Okay, now we should be able to do something. Let's try Shaper Calibrate. That sounds very familiar. No. Even the test resonances is probably not going to work. So, no, it is. Okay, so test resonances is working. So you can see now we are testing. So Shaper Calibrate might have been a different one, but now you can see we are testing our resonances now. So we're going to sound like a jet engine here any second. No, Delmar, I didn't do that, but sudo Raspberry Pi config and enable SPI. Let me finish this one and let me do that. Obviously, oh, maybe I don't need to. If it's working, I should be good, right? But what's the code for doing them both at the same time? Now let's switch over to the console. Here's where we're going to hear. You're going to hear the vibrations. Oh, I better not do that. Here we go. And we're going to quiet up again. Oh, shape calibrate does both, one after the other. Okay. Shaper calibrate, shape calibrate. I mean, it's not like I'm going to do it every day, but once I get the printer in its permanent home, I'll run it again. Because right now it's on the Lazy Susan, so it's going to change once I get it onto a solid surface. And we are at 122. I believe it goes up to 135 hertz or something in the 130s. 130, 131, 133. Okay, 133. I knew it was in the 130s. So it should spit me out some numbers now. Misspelled it. Oh. I misspelled it. Okay. Doesn't surprise me. Well, it looks like it's running through it again. Or it's doing X. Maybe it is doing both. Yeah, it's doing both. It's doing Y now. Let's see. First one was X. Yeah, it's doing both. Aha. Oh, you did. Oh, okay. Okay. Okay, we're going to get loud again once we get into the 150s or so, nor the 110s. 110 when it gets loud? Well, that's not as bad as the X was. Oh, it's only going up to 86 for this one. Oh, no, there it goes. There it goes. See, the software is lagging for some reason. There was a pause there in the software, and it took the software a while to catch up. So there's a communication thing between the software and the Pi. Anyways, whatever. You got done putting the mini stealth burner on your salad fork. You did this in about 3 hours ago. Nice. Okay, here we go. Oh, you know what? It's doing it again. You know why? Um, there's a lag. So when I entered the first command to do it, it just stopped. Nothing happened. I entered it again, and it worked. And then it's just catching up. There's a lag going on here, and I don't know why. So we're just going to go through this once more. That's annoying. I don't know if it's my computer or if it's just something with this particular Raspberry Pi, or if there's a Wi-Fi issue between the Pi and the computer, and there's a something, you know. Yeah, but this is a new, faster computer. It's weird. What's vibrating on there? Something like. Anyways, yeah. And then this is the first time it's done it with any of my builds, so that's why I'm suspecting communication between the computer and the Pi for some reason. I could always try plugging a network cable in, see if that little lag goes away or that little delay. But anyways, it is what it is for now. The main thing is it prints fine. When I send it to print, it's not affecting the actual performance. It's just affecting. It's like a delay. It's almost like a stream delay, you know. See right there, it's frozen again. See at 104. Now you'll see it's just going to all of a sudden it's going to go zip 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 down to where it was, because that should be going line by line still. But in about there we go. See, now it's catching up. The software is catching up. There, just like that. So there's something happening. Measure the voltage of the PSU and tweak it up to 525. Really? Okay. No, I'm powering the Pi off the main board. Okay, so that's not what I want to do here. I don't want the file. What I want to do is I want to do the other one we did where it actually save config. So I'm going to rerun this, except, yeah, I'm going to rerun this. I'm going to rerun Shaper, calibrate, and we're going to do this. There we go. And I want to do this so that that I can just hit the save config, because I'm going to use its suggestions. Golden Jaguar, am I going to put panels on the machine? I will eventually, yes. I've already decided that I'm going to use white panel clips, just because I've made this thing so colorful. I'm gonna run these white panel clips, and use these because that'll kind of offset or highlight all the colors on the machine. If I have the panel clips, it'll make all the colors kind of stand out. So I will eventually put the covers on this, but I haven't printed any of the parts for it yet. I have, Nick, I have a 5-volt PSU, a Meanwell. I could throw in there, I could power the Pi off the 5-volt PSU, but basically the instructions for this particular build for the LDO Trident was to power the Pi off of the main board with that adapter that we put on there where the accelerometer was plugged in. But everything's working fine. I don't know if it's a power issue so much as maybe a Wi-Fi. Something is interfering with the Wi-Fi signal between the computer and the Pi, because everything is going and doing what it's supposed to do, but the data, I suppose, if you want to say the data transfer or the data transfer between the two is something's causing a hesitation. Just like you see on screen right now, it's stuck at 96. And then all of a sudden it's going to speed up just like that. We're going to go all the way up. So it's like it's stalled sending all that data over. So, yeah. Golden Jaguar, I have the panels. I have them all on the floor down here. I'm going to throw probably, I believe it was Zixelter who sent me this. Somebody sent me this a long time ago and I didn't use it. But I think I'm going to put this on the back, on that black back panel that goes on the back of this big Voron logo. That'll look really cool on that. So that was meant to go on the 2.4, but I forgot to put it on. And now we're measuring the Y. And then this time we're going to get the save config option, and we're going to do it that way. I'll still be curious to see what it suggests as far as shaper. Your drip, it was a sonar issue. Huh? Really? Please don't have the best Wi-Fi. Pis don't have the best Wi-Fi. Yours was dripping. Oh, dripping connection. I like that terminology. That kind of makes sense. See right there, we're stuck on the 44 hertz. It's going to then go and say, oops, I got to catch up. Let's send all that data over. Dripping connection. I like that. That's exactly what it's doing. And there we go. Look at that. It's catching up now. It's more of an annoyance than anything. Yeah. Dropping. Oh, I like dripping. I like dripping. I mean, yeah, so it's just dripping little bits of data at a time. A sonar issue. Interesting. Dripping and sonar. Okay, here we go. And we're frozen at 125. Come on. Spit me out my data. There we go. Okay. Blah, 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 blah. Okay. So it's looking for recommended shaper for X is ZV, shaper frequency 63.8. Recommended shaper for Y, MZV, shaper frequency 42.8. I usually just go with what they suggest because this is all goobly gob to me. Am I printing from my underground layer? I am. Yes. It's my bat cave. Now, I screw this up every time. Every time, and I've learned. This is going to show you guys I'm listening to what you say. I would now type in here save config. I know I can go up right here and click save config. Look at that. Look at that. See, I learn. I learn and I listen. Come on, reboot. Reboot. There's this delay again. Because the printer itself is ready to go on the screen, but of course now it's, right now is when I would go, oh come on, what's going on? I'd refresh and do all this stuff, but if I just wait, there we go. So there's that dropping or dripping connection that we talked about. So okay, so now that that's done, I'm going to unplug accelerometer, and we're going to tuck the accelerometer. For now, I'm just going to throw it under here because I don't have a bottom cover on here, and I don't want to pinch this wire under anything. So we'll just kind of tuck it away right here for now, just while we do some other stuff. Okay, cool. Now, I'm going to start the bed heating because we're going to do a print here for the next test. If I recall reading ahead correctly, I'm not 100. We only need to heat this to 65, just because the bed takes a little longer to heat up. Nozzle heats up very fast. So this is where I'm going to basically get into Andrew Ellis's tuning guide, which is what I used on the 2.4 when I did the tuning on that. And so we've done the extruder calibration. Okay, build surface preparation. Oh, let me show you guys what I'm reading here. Okay, he's changed it up a little bit actually. It's almost like it's got its own home now on ls3dp.com. And this is new. I've not seen this layout before for it. So we got the extruder calibration, which we've done, which was basically the E steps. We did that as soon as we got it printing. We calculated the E steps and then did the test print on it. And then we didn't have to make any adjustments to that. Build surface preparation and handling. While we've taken build surface preparation, I'm pretty familiar with, etc. First layer squish, I'm not worried about that. We've calculated our Z offset. We're using Z calibrate to get the perfect first layer every time by using the clicky probe. Okay, so first layer squish is taken care of and it's fine. If we look at these cubes that were printed on the first two test cubes, and we look at the first layer, I mean, we've got really nice looking. It's easier to see on the gray one. We've got really nice looking first layers. We have no problem with the first layer squish. We're not seeing any layer lines, any under extrusion. If anything, there's a bit of over extrusion happening on this. Okay. Pressure advance. So this is where we're going to go first, to pressure advance. So we can read through all this, but I'm sure we all know what pressure advance kind of is. It's basically the pressure that the filament is being pushed through the nozzle at any given temperature. That's my take on it, my Cole's note take on it. He gets into all the different, he gets into everything as far as the technicalities behind why you need to do this. I just do it because pressure advance to me is making sure that you're getting the proper pressure so you get proper layer adhesion. I always get pressure advance and flow calibration mixed up. Or is it pressure advance and flow calibration, or is it, there's a couple that I always get mixed up. But anyways, pressure advance, why is it needed? See, to me, I think it's something to do with slowing down at corners and then speeding up after you get around the corner. So as you approach a corner, when you're going to turn your head, it wants to lower the pressure. In other words, because there's already so much pressure built up in the nozzle that as you slow down, if you don't reduce that pressure, it's going to make your corners too fat. That's kind of what I get from this. And then as you round that corner, you have to increase the pressure again because the head's going to go faster, and you're going to start extruding filament again along that long line. So that's my layman's term for explaining pressure advance. So if I'm wrong, forgive me, but that's kind of in simple terms, like, so a 4-year-old could understand it. That's how I, how I look at it. Well, that's the thing, Steve. Exactly. He has a lot of theory in it, and I usually skip by a lot of the theory. This is just an interesting little chart here that just tells you, yeah, when you slow down, if you don't, you know, yeah. Anyways, yeah, the theory, that's why I say I don't necessarily need to know the why it's doing it. I just need to know, hey, it's improving my prints. Let's do it. So most people that are into they buy these print and go printers that aren't building them, that aren't tuning them. They don't care. Their corners look fine, their pieces are fine, and it's fine. But when you're building a machine like this and you want high quality prints, then yeah, we want to tune them. So Cully5, the best way to send me a link is to temporary mod you, and go ahead and post a link for me now. That'd be perfect. So again, look at all this theory, explanation, what it does. I'm not getting into that. If you want to learn about it, go to Ellis's tuning guide. He gives you all the technicalities of what it does, and you can definitely overstimulate your brain. And yeah, and he even gives practical print examples of what Pressure Advance does. So that's a whole separate video if you want to learn that. But there's a lot of people out there that have explained this. I believe 3D Print General, or no, Stefan CNC Kitchen has gotten into this in great depth as well. So yes, I'm going to do the new test. Signs of issues. He gets into all the details. So if we go ahead and, okay, there's the introduction to Pressure Advance. Pattern method. Okay, this is his new one. He's got a new pattern method. Is this? I think this is the one you're talking about, Delmar, right? Because he's got the pattern method, and then below the pattern method is the tower method, which I've done before, which relies on looking at the corners, etc. And then the last one I did was the lines method, which was this one. I did this one on the 2.4, but it says right there deprecated. Now, I'm an educated man, but I'm not 100% sure what the word deprecated means. But I'm going to use his pattern method here because it looks like this is his newest method, and it looks like it might be the easiest one to, get the proper reading off of. So, okay, I'm going to look at that, Collie. Actually, right now, before I go on, thank you for that link, Collie. I'm going to open that link right there. And then I'm going to, there we go. I'm going to leave that window open, and I will look at that after. And I will do that. Thank you so much. I appreciate that. Deprecated, out of date. Okay. I thought like discontinued, or when I first read it fast, I said it was decapitated. It's like, okay, you decapitated your method. Okay, so this basically shows the pattern we're going to print. Okay. What to look for. So he's marked in green the ideal one. Why these ones aren't ideal, because we got bulging, and why these ones aren't ideal, because we've got thin gapping pulling away, so bad adhesion, etc. Okay, so saving your value. Now there's somewhere in here calibration tool. So I need to go to this link here, and this is going to generate my G code, I hope. I think all I have to do is download the G code for the Pressure Advance pattern right here. Print tuning guide, Pressure Advance pattern. These are the settings. Okay, well, first we do our settings then, right? Clipper, nozzle diameter 0.4, 1.75. Extrusion multiplier, I'm just leaving what he's got here. We worry about extrusion multiplier later. My bed size is 250 by 250. Travel speed, I'm going to leave what he's got set there. Everything else I'm going to leave the same. Anything more specific to my printer, first layer settings, we'll leave what he's got here. First layer print speed, print settings. Let's just see, where is the, there's our Pressure Advance stepping, start and end G code. Now, where is my, I'm assuming temperatures. Let me save the settings in the browser. Where do I set temperatures? Because I'm going to run, yeah, some customizations for mine. I'm looking for, so I got my bed size changed. Let's go advanced mode. Maybe there's temperatures in there. Print settings, line width, print speed, layer count, fan speed, start and end G code. Well, where, maybe I just didn't read it enough. Maybe it's assuming it's going to be PLA.
Dad?
Yeah, hang on one sec, folks. We have our special visitor here. Hang on. Just chill for a second. Let's see. Here we go. Go for it. Now, you're on camera. Go, look.
Hit that like button and subscribe.
Bye.
Bye.
Okay, there we go. Woohoo.
Now, actually, goodbye.
Actually, goodbye. Oh, he said actually goodbye this time. Start NG code as temps in the first line on the left. Oh, okay. Let me have a look. Start NG codes. G28. Print start. Actual start G code. Oh, right there. Sorry, bed temp 60. Hot end temp, we're going to go 215. I'm running, I'm going to put some Jesse PLA in here. And bed, I'm going to run up to, thanks for pointing that out, Steve. I probably went right by it. And 65 for the bed. It's chilly down here. And then we'll go ahead and save settings to browser, and we'll download G code. So we have the PA pattern G code. So let's minimize this. Let's open up Clipper. Where is my, where? Oh, it's right here. Come on. There we go. And we will upload a G code file. PA pattern, open. Let's get some filament. I have not loaded filament. Before I do that, I have to put the filament holder on. Aha. I just want to quickly put the filament holder on. It's just one of those steps of the build that I didn't do. So we're going to raise that camera up a little bit there. And I believe I just need, it's an M5. So let's grab, these are M3. I think my M5s are back here. You need to review the start and end to make sure it will use your print start macro. Oh. I totally spaced out on that. Totally spaced out on that. What is my macro called? Start print or print start? Start print or print start? Let's just see. Print underscore start. Print start. So I can get rid of all this stuff. Start, oh, right here, print start. Aha. Print. Why won't, will it not let me change it? Oh, right here, sorry. Print start. There we are. That's what I need, print start. Oh, it already, official start macro name. So it was already there. Oh, man. Passing variable with his two variables added for the hot end and bed temp. you also have to add the passing variable. So I didn't need to do that. Print start was already there. Print start is my start G code, which is what my macro is. Okay. And then you're saying, and I have to add the passing, oh, sorry. I have to add the passing variable with his two variables added for the hot end and bed temperature. Passing variable. So I've put in my temperatures. And what's my print NG code? I just want to make sure that I have that correct. I think it's called print end. Yeah, it's print end. That is correct. Oh, I see. Okay. Okay. See, there's what I mean that I'm guilty of not reading. Okay, so what he's basically saying is I can take from my slicer my actual start G code and paste it right in here. Okay. Makes sense. Yeah, I think it's already there. Okay. Start G code, actual start G code, NG code. Okay. Okay, so now I can save setting to browser, and then I can download this G code file. And I can get this one ready in here. Pattern, yeah, that's still going to be the one with the 1 because that was the one I changed. Okay, let's get the, thank you for pointing that out. That's me being guilty of skipping over reading stuff thoroughly. I am bad at that, and I have to, that's something I really need to change. So kids, read the instructions carefully. Let me just make sure what size I need here. That's an M516. That should be plenty because I don't have anything in between a 16 and a 30. Yeah, 16 should be fine. And then I just need an M5 T-nut. Yeah, T-nut. Hammerhead won't work. Right. So let's go ahead and throw the T-nut in. I'm going to put the spool holder off to the side. And I don't know where I want to mount it, but hey, Bear Cool, how are you, sir? Welcome, welcome. Okay. There we are. Okay, get out of there. One spool holder. And I think this one is an M3. Yeah, does that go down or up? I don't remember. It goes in that way. Oh, that's on the top. Oh, that's why. This one here, an M3 T-nut. Yeah, I'm Stephen. I'm bad when it comes to reading stuff thoroughly. And anybody who's watched any of my other builds can attest to the fact that, yeah, I tend to miss things by not reading thoroughly. Did I have one up here already? I don't. There we go. Yeah. I don't know if it's human nature, what you want to call it, but you know. Yeah. Actually, and speaking of glasses, and there's my other excuses. These glasses I have on are 11 or 12 years old, and I just ordered new ones last week, so I do have new glasses coming in. They're just not here yet. Is that not going to work with a T-nut? No, it's not. That's going to need to be a hammerhead nut. Yeah, I'm going to need a hammerhead on that one. It's not going to fit in between that. Or will it? Hang on, did I just rush that? Let's just see. Oh, not quite. No. Okay, need a hammerhead. There we go. That's fine. We have lots of hardware. Let's put a hammerhead on this guy. This is just the filament guide. Oh, come on. Come on. Okay. Throw this in here. Yeah, I think right about there is fine. Okay, let's get our Bowden tube. I had the Bowden tube out. There it is. Our reverse Bowden. Yeah. Okay, let's go through here. Oh, that's long. Is that me or is that really long? I didn't have that long piece in there. Wow. Well, I won't shorten it yet. Okay. That's really long. Considering, yeah, I can actually shorten that quite a bit, actually. So even when I have my back cover on, it doesn't have to be that long, because really it's just got to go. There's the maximum length right there. So I can cut this. I'm just going to cut this off. I'm going to leave myself a little more than I really need. There we go. Okay. There we go. Okay, now filament. Let me think. To see this test, I should actually go, I wonder if I should go white or something light. Let's do this gray. Let's do gray. The Grat Kit Gray PLA. Grat Kit Gray PLA. Don't unspool. Hey, John Strand. Hello. How are you? Okay. Let's get this pushed in and through. Come on. Get right down in there. There we go. Okay. Filamento lodedo. Okay. Let's go ahead and run that print. And we'll see how we do. Bed's up to temperature, so we don't have a whole lot of waiting to do now. See what the cool kids are working on. We're just doing the tuning on the printer. We hooked up the accelerometer. We did the input shaping. Now we are doing pressure advance. I have to take my slicer variables and substitute Alice's. Look at the blue text above the box. Did I miss something again? Okay, I got to read this more carefully. Oh. I thought, okay, hang on a minute here. Why? So obviously something, bed temp, hot end temp, extruder name. Well, is it not going to get that from my macro, from my startup macro? No, it's obviously not getting it from my startup macro because it's not doing my startup. Okay. Yeah. Okay, let me, first of all, we're finishing. Let me stop that print. Okay, bear with me 1 second, guys. Yeah, I didn't do my proper startup procedure, so obviously my start G code, my print start G code did not work. But first of all, I just want to make sure that, I'm going to get my hot end hot, 215. I just want to make sure the filament's coming through. Because it started to print something, but the filament did not seem to come through. So I'm going to make sure that I actually have filament coming out. And did I not push it in far enough? Huh. Why? Oh, I know what happened. When I locked my head back in, I didn't. The little side piece was not locked back in, so no wonder it wasn't pushing any filament. It should be okay now. Let's just make sure. Yeah. Okay, give me 1 sec, Delmar. I'll have a look. I just want to make sure my filament's coming out now. I've done that before, where I open the lid and this guy falls out, and then I put the lid back in, and this hasn't re-engaged. Yeah, now this whole thing is just frozen again because it's not climbing and it should be, but that's going to pop up. There we are. Okay, now let's make sure I have filament coming out. No, what is going on with my extruder here? Something's going on up here with my extruder. Hang on. My gears aren't engaging. Yeah. What next? What is something is wonky here. Did I break a piece in here? Huh. Isn't that typical? Something's not right. It's not engaging. Something's either broken in here, or if I tighten that a bit more. Is that screw? Let me check that one screw in there, that micro adjuster, whatever we want to call it. Make sure it's not too loose. Move over a bit. There we go. Try that. Yeah, well, it's that little grub screw inside that prevents it from closing too much. That's the one I'm looking to see if maybe it has vibrated loose or something. Let me try again. That seems better. Yeah. There we go. Now let's see. There we go. Did that cool down on me? No, it didn't. Why? Okay, we grabbed it now. Maybe. There we go. Okay. Yeah, I think that little screw came loose. There we go. Now we got filament coming out, no problem. Let's just do 50 more to be sure. Yeah, there we go. You can see it right here. Okay, well that issue taken care of. Okay, now let's go look. Yeah, Bear Cool. It was the little I don't even know what you want to call it. It's that tiny little M3, like a 4mm, 3mm screw in there that's added in there so that you can adjust it so that your gears mesh tighter or looser. And it looked like it had just backed right out for some reason. So okay, let's go back. Take your slicer variable, substitute LS's, look at the blue text above the box. Read your G code to see if you have the numbers and temps are there. The numbers and temps are there because it heated up to the proper temperatures, but it did not do my start G code properly, even though I copied and pasted it from in here. Now, I think that's because, okay, I'm going to go ahead and basically start this over. I'm going to go back to here. I'm going to go back to the tool. And we're going to basically start this from scratch. Oh, it didn't change anything. It kept it. Oh, it's because I saved it, didn't I? Yeah. How do I reset it? Got to be, restore defaults. Let's do that. Okay. 250. 250. Okay. And we had to come down here. My temperatures were 65 and 215. Speaking of which, I'm just going to quickly go through here and get the bed warming up again. Okay, now, print start is the correct macro right there. So I'm going to leave that. That is my proper start code for the macro. And it should pick up my bed temp, my hot end temp, my extruder name. It'll get that all from the macro. I'm positive. Everything else should be fine. Print end. And that is the name of my end macro is print end. Print start. Okay. Okay. Let's just try it. Download G code. Let's go in here. Let's get rid of this one here. Okay. Yeah, delete. Or whatever. Oh, it's that delay thing, for frig's sake. Okay, anyways, let's upload pattern 2. Yep. And print. See what happens here. Let's see what happens. See if it does my actual start G code now. Why are you going? Why are you going to 110 on the bed? Ay, ay, ay. No, no, no. Oh, okay, I'm obviously doing something wrong here. Okay. This lag is annoying. Copy your slicer start code to LS guide and change the information into the, okay, let me stop this. Come on. This lag too, this delay is or this dripping is really getting annoying. I don't want the bed heated up to 110, but it looks like it's not going to give me a choice. Okay, let me find my start G code. Now, just out of curiosity on this one, yeah, this is just it shouldn't matter what I have set in there. This is my start G code right here, which some of it's commented out, but what the hell. Let's copy that start G code. We'll just let the printer do its thing. Actually, no, I don't want that to heat up that hot. Let's restart. Restart. Start G code. Let's paste that in here. There's our starting G code. Now you say do an e-stop. Yeah, I may have to because this doesn't seem to want to slow down. And then let's restart. Oh, good. At least the fan's smart enough to keep the hot end cooled down. Oh, man, that lag. Okay. Change the information in the brackets. Okay. Bed temp. Okay. So we're going to change that information. But we've already got the bed temp changed up here. We've got the hot end temp changed here. Okay. Extruder, first layer temperature, initial tool. First layer temperature, 215. What's that initial tool thing coming in? Bear with me 1 second. Yeah, initial tool. What is my... Okay, so we can get rid of that. So I could basically go 215. No, I don't need... Oh, I got to take the brackets out. Bed equals 65. Yeah. Yeah. Okay, so there we got that. Or do I need... I don't think I need to leave those brackets in. No. Okay. Extruder equals 215. Bed equals 65. There we go. Why did it not do my proper start before? Print start extruder. What I did should work as well. Okay. But it's supposed to do a mesh level, a Z calibrate based on my print start macro. Actual G code start. Now, is this actually overriding the stuff above it, though? Click the start G code preview below. Check over the start G code before printing. Okay, so we're going to home all axis. We're going to set and wait for bed, set and wait for print start extruder 215 bed. But it's commented that out. Why is it commented that out? Because that's actually not what we want. Damn. Yeah, and right, the start G code's not going to, it looks like it's not going to go to my print start macro because it's commented it out. I can't change this yellow box. Yeah, I can't change the yellow box, and it's commented out my print start, which tells me it's going to ignore my macro. Oh, there it is. Ah, I just had to put a space in there. That might. Where's it getting those comment? Those So if I back that up, it's going to be there, but they'll be commented out. This delay is really, really annoying. Okay, let's just. There we go. There we go. So we'll start it up again. We'll get the bed to 65. There we go. Click don't add G28 box. Oh, okay. Don't add G28. Oh, okay. It still doesn't. Okay. The only way I can get rid of the commenting out of my print start G code is to put an enter there. It's going to move this one down to the next line. It'll take the, I don't know if that'll still run that print start G code or not. Don't add G code, heating G codes. That's fine. Doesn't matter. Okay. Oh, I see what you mean. Make sure they did not mess up their machines. Okay, Brendan. Thanks for being here. Appreciate it. The M190 and the M109. Oh, those are my start G codes, M190 and M109. Get rid of everything before the print. Yeah, because those are commented out anyways. Oh, those are what were causing. Ah, okay. Okay. I see what you're saying. I get it now. But we need this to catch up. Okay, that should work right there. Okay. Let's see if this is going to work. Don't wait. Don't click add heating. Don't add heating G codes. Okay. Okay. There we go. Okay, so this should work. And now it'll follow my print start G code, which is going to tell it what to do as far as heating and everything goes. Okay. Let's give this one a shot. This will be number 3. It's all so confusing, but hey. Why won't you let me delete these? Oh, now you will. Sure, make me a liar. Okay, let's see what this does. Okay. We know the filament's feeding because we fixed the issue up there. See, there's always more than one issue going on here. Bed is warm. We're heating to 150, which we should, because my G-code macro, oh, stop that face detection right now. Get back where you belong. Because my G-code macro tells it heat 70% of the final print, which now, so my bed is heating, or my hot end's heating to 150. which is what I want it to do. So we should be okay now. Oh, thanks, Mike, and hello. Okay. So we should start up any second. There we go. Okay, let's see if this works. Oh man, talk about the long way to do something, right? Whoever said this stuff was supposed to be easy? There we go. Now we're doing what we're supposed to do. Okay. And over here. Oh, over there. There we go. We're doing our Z tilt adjust right now. Look at that. That was quick and easy. One time around. Oh, Odin tube. A little bit long there. There we go. Now we're going to do our Z calibrate. Oh, we're homing it. I got to take some. I've got too many homes in my macro. I need to tweak my macro a little bit. Oh, okay. Oh, that's right. Just a macro for Pet Giant. Yeah. I'm not all that well versed at writing macros and doing that. So I need to practice a lot more on getting the macros down. See, Clipper on the screen just rebooted itself, but the printer's fine. Now we are doing our Z calibrate. Okay, and then we're going to do our bed mesh, and then we're off to the races. Finally get this test printed so I can get on to the next test. Jeez. Macros are the bomb. They are. But I got to learn them and how to use them. And yeah. Nice thing about macros is somebody's written them already. Just need to learn how to tweak them. Now we're just doing our mesh. It's 25-point mesh. If you know the syntax, is syntax not an alcohol tax or something like that? That's to me what syntax means. A tax you pay on beer and booze. Meanwhile, let me look at that sonar thing. Oh, so you install a sonar thing. Updating via Moonraker's update. Okay, so that's just a simple matter of updating, doing a sudo git clone, GitHub mainsail, sonar git. Okay, so it's like installing sonar or something in your Pi, and it's okay. Well, we're going to try that. Maybe after this print, I'll do that really quick because it's still doing it. It's every once in a while, the clipper on here, like this here, will just sort of reload. It'll just like almost like it shut down and reloaded, but it's not affecting the actual print. Okay, here we go. I'm going to home once more. But where do you get the good ones? You need to try the screw adjust calibration in Clipper, but you've gotten your mesh under 0.1 across the sheet with blue tape shims. Ah, see, there we go, right there. See, it rebooted itself again. And then it's going to pop up. But it's not going to affect the print. So hopefully that, yeah, it's lost connection. But we're still going because the hot end's heating up. So hopefully that sonar is going to fix that issue. Well, let's just see how long this takes to boot. But in the meantime, the printer's got to print here. And we are going to start printing any second now. Ooh, stringy. Ooh, that is really stringy. Still hasn't rebooted on the computer. There we go. We're printing anyways. That's fine. And in the meantime, look, we're still getting this. So, but the display on the printer is working fine. Here we go. Okay, so we're going to print that pattern. No, it's PLA. Yeah, and it's still, oh, there it is. So now it's started up again. It took that long for that to come back on. I did if recent mainsail install, it should already have sonar. Okay, do I have any updates? Let me look and see if there's any more updates since then. I do have a mainsail config update to do. That's the only update to do is a mainsail config update. But yeah, I don't know. My other printer doesn't do that, so it's something with this Pi or something. Anyways, well, why don't I put a camera up higher for you guys to see what it's doing up here? Oh, we put one of these up here, and this one here. There we go. You guys can see what we're doing up here. Thank you so much, Mike. Appreciate that. Yes, we got a lot of content coming out in 2023. So yeah, hit that subscribe, like, anything you like. Do it. Just do it. Dum, 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 dum. It's like we're printing, what are those bars called on the shoulder of a general or something or whatever, or a colonel? We're printing the bars for the shoulders of their uniforms. Oh, and by the way, I can't get my LEDs on my hot end to work. I don't think I've got the wires plugged into the right spot on the main board. Chevrons, that's it, old curmudgeon. Yeah, I don't know, OC, if it's, I've never heard of sonar other than, in the ships where they have sonar that, they ping submarines and all that stuff. So, a lot of wasted travel moves. What, on this? It's a test, though. This is a test. This is a pressure advance test. So those moves are probably done like that on purpose. So if I go back to his, then we got to know how to actually then program it. There we are. Which Pi? It's a Pi 4B V2. Ah, okay. So yours was a 4 and no issues with a 3. Hey, Richard. Nah, no problem. We're doing, we had to do a few little, we had to jump through a few hoops here. We finally get where we're actually running a pressure advance test right now. And this is the Ellis print tuning guide. And this is one of his test prints for testing pressure advance. So once this is done, what we're going to be looking for, if you see right here, so this is the file we're printing here based on his in his guide, and this is what we're looking for. We are looking for the sharpest corner of all the chevrons. So we don't want these ones here, as you can see, they're not adhering. There's a little separation. These ones here are bulging at the front. So what we're going to be looking for is the sharpest corner. Oops, wrong camera, and this is what it's printing. My 2.4 is a, oh gosh, I think it's a 3. So I wonder if it's an issue with the Pi, because it doesn't do it on my 2.4. Another novel way of testing things. Yeah. Official original Raspberry Pi 2 Model B dev board Broadcom BMC2 1 gig RAM Raspberry 2 B are on sale for $59. $25 off. You got an email last week. Wow. Can you run Pi 2Bs on these things? Why is it? Oh, I see. Okay. We're just running multiple lines, in other words, to see how the corners look and how the it just looks on the camera. It looks like it's meshing them all together, but it's not. It's just the angle of the camera. This is an interesting test. Yeah, it's got to build a few layers. Yeah. Well, my input shaper is working fine on this Pi. A Pi 3. Oh, you're saying a minimum Pi 3 to run input shaper. Okay, I get what you're saying. There's a Wi-Fi issue in the main sale Discord, as someone else said, but I know that link fixed yours. Okay, well, I'm going to try that, Collie5. We're going to try that. Okay, so we're done the test print. So let's have a look. Let's pop the bed off. Okay, and let's have a look. Very cool. Okay, now let's get a camera here. A Pico. Okay. We have this camera here. Let's see if I can get without spilling water on my keyboard. There we go. Whew. Let's see if I can get this camera to look down on here. Oh, wow. Okay, so here, what I'll do is I'll hold it up like this. Oh, sorry. Oh, that's because my wire is stretched. There we go. So we're going to hold it like this so we can all see it. Now, is it going to focus for me? There we go. So there's what we're looking at. Oops, let's do it this way so we can actually read those numbers. So now what I have to do, and it's going to be easier for me than you guys probably, is I have to find the best looking corner. So we can see, you can just see what's going on behind the scenes here. We can see that this one's got separation, which he doesn't want. Separation. So we want down here. So we're looking in close to here. Up here, you can see we have a bulging corner. Bulging corner. So we're looking probably, I'm going to say this one here or this one here. So Golden Jaguar says 04. If I come down 04, yeah, 04 is the first one I thought of right here. So either 04 or 035. So I'd say we're right in this range right here is what we're looking for. Yeah, 035 between 0, because 04's got just a tiny bit of separation in there. 035. 0.3's got no separation, but we got a tiny bit of bulging. So if I come up to here, yeah, that is 0.3. So I'm going to call it 0.35. 0.35 has gaps. Yeah, right there in front of that, you're right. 0.3 on an angle. Yeah, so yeah, actually on this angle here, the first one with no gaps is right there, which is 0.3. Yeah. And I would say that there's, forget that little hickey there, or whatever. I would say that there's no bulging. You can see the bulging starting right here. So yeah, let's go with 0.3. Yeah, let's go with 0.3. I like this test. This is a whole lot easier to read than his last one. Okay. Okay, so we'll go with 0.3. Yeah, good angle there. Get back to where you belong. No, no. There. Okay, let's go with 0.3. So let's see what he says here. Let's put this aside. That's a cool test. So we've determined 0.3. Okay. So now, yeah. So this just tells you what to look for here between 0.2 and 0.4. That's true. If I want to get that, yeah. Oh, the clipper test wants you to run a little tower, and yeah. So saving your value. So if we go here to saving your value, it says, okay, so in the extruder section of your config, update the pressure advance to the new value and issue a restart. Alternatively, in PSSS, you can manage this per filament by putting set pressure advance equals value in your custom filament G code. Okay. Well, we're not going to worry about the per filament yet. So we're going to go into the extruder and pressure advance system. So let's go back to our, see, there we go. We've lost connection again. This is getting annoying. I can hit try again, but let's just see. We're going to run and do that. We got to remember 0.3. Oh, you do a second one in Super Slicer. Okay. You put it in your custom G code because it changes for all your types. Yeah. Can I drop a link for the tuning? Yes. It is Ellis's tuning guide. What I'll do is I'll go to his main page so you can get to the beginning of his tuning guide. Let me go to his main page. Here we are. And let me drop a link here for you. Copy and is it going to go? There you go. There you go, OC. Still not. See, but I don't think it's my Wi-Fi issue because it's not affecting my stream. Oh, come on now. It's going to come back eventually. Meantime, let's go ahead. Let's go ahead in here and see if let me run that sonar. Let's just do this. Let's come here. I think I got to restart my session. Because we're fine on the printer. On the printer, we're fine. We're set. We're ready to go. But it hasn't translated over to the computer yet. I mean, this is, we're done. Anyways, let me refresh the window or something. I don't know. This is there now it's come back. So let's go ahead and do that. Where's my terminal window? Let's SSH into the Pi. Okay, and then let's run that command. Where was it? Let's see. Copy that, bring it over here. Right mouse click. You'll see something's it's stalled up again here. There we go. Okay, continue. Yes. Please enter path. I don't know the path. Default. Okay, so we're done. Okay, so let's see if this helps it. So we've done that. Make install. We've done updating Moonraker's update manager. Okay, so there's one more thing we're going to do while we're on this. Okay, so we're going to go, and there was an update here. Main sale update. Let's do the update just to make sure we're up to the latest. Now we're going to stall again here. Maybe I needed to reboot. Oh, here we go. Updating main sale config done. So that update is done. Okay, we're going to reboot. We've got the sonar thing in there. Let's just go ahead and see what this does for us. Okay, so now we need to go to our printer config. And it said, let me just make sure, under the extruder section, pressure advance. Extruder, let me just quickly find that. Extruder. There we are. Let me close this. And pressure advance is under here somewhere. Let's find pressure advance. Right here. Pressure advance. We'll uncomment that. And we were 0.03. There we go. Okay. Default is 0.04. Leave stock. So we've determined it's 0.03. We'll save and restart. There we go. Okay. Line 242. Now you tell me. There we go. Okay. We did that. Okay, let's go over here. I think I was on this page here. Whoops. This one here. Pattern method, tower method, saving your value. Extrusion multiplier. Here we go. Here's our next test. Last stream you did a Z end stop calibration. Was there a site for instructions for use with a clicky probe? Ooh, yes. Man, I got that link from Golden Jaguar's stream when he did that. Are you still on here, Golden Jaguar? Let me think about that for a minute, Zenbender. Yeah. And playing with the switch offset manually to get your first layer height. Yeah, there is, because I got that information from Golden Jaguar's stream when he did that. And that's the instructions that I had followed I believe he had a link to it. And even with the switch offset, it does not necessarily mean it's going to give you your first layer height, because the switch offset, I had to end up playing with those numbers until I came within my tolerance. But you got to keep in mind, what I keep forgetting to do is, this one. I keep forgetting to do my Z offset calibration first. So you want to do your the paper test Z offset calibration first, get that locked in, and then do your Z configuration numbers. And then that will give you the first layer. I forgot to do that on both of these printers. And so that's the step that I had missed. So you're using mainsail. There we go. But that's the step that I had missed, was the doing the Z offset calibration and then doing the Z calibrate. It was a little confusing for me at first, but I will try and find that for you. Yeah. Okay. Let me, I got about another 50 minutes left. So calibrate your extruder first. We've done that. Tune pressure advance. We just did that. Okay. So now I don't want to learn all about, I really don't want to, I don't want the science behind it. Print settings. Okay. Top layer. Okay. So method. The best method I have found is purely visual and tactile. We'll print some 30 by 30 by 3 millimeter cubes. See the test prints folder. So let's go to the test prints folder. Is it going to open a new window? I don't like when it doesn't open a new window. Extrusion multiplier cubes and labeled, unlabeled, labeled 0.5 to 8. Which one do I want? You raised 0.03 millimeters, then adjusted after the print is done. Okay. You adjust your switch offset to high number for closer to bed. Yeah, high number is closer to the bed, lower number is further. And leave the Z offset alone in printer config. Yes, but you have to remember you raised 0.03, then adjusted after the print is done. Okay. Extrusion multiplier 0.8 to 1.2. I think I'm going to fall into that range. Let's see. So, oh man. I don't want to print all these cubes. Okay, hang on a minute. Let me go back and make sure I know what I'm doing. Back. That's why I wanted to open a new window instead of having it in the same window. But I think if I right mouse click and tell it to open a new window, it will. Extrusion multiplier is a huge part of achieving good looking prints. There are some, examples. Method uses aesthetics first approach. 4 concerns about dimensional accuracy. Okay, so this tells what to print, but the steps: slice the test cubes with a variation of 1 to 2 extrusion multiplier. Oh, I get it. Okay. There is no way to set the extrusion multiplier per object. You'll have to print the test objects one at a time. So is he saying I have to print all of those test cubes? No. You know what I want to do? Because this one looks like it's going to take a while. Hang on. Cooling and layer times, retraction, infill, perimeter overlap, step over. He's got a lot of things that you can go through in here, but I think extrusion multiplier requires printing multiple cubes at different extrusion multiplier settings. I think what I'm going to do, since we've done pressure advance and input shaping already, is I just want to print a test cube now and compare it to the 2 that we did here. Now, yes, the extrusion multiplier is going to have a little bit of a play on the quality, but it's not. I should notice less ghosting and much nicer corners. It only requires 2 cubes. One set to the second, one to set it, and the second to verify it. Okay, but he's saying here, failed to stop. I don't stop. Whatever you're telling me. Not you guys, the camera. My camera's being annoying. Slice the test cubes with the variations of 1 to 2% extrusion multiplier. In Prusa Slicer, there's no way to set the extrusion multiplier per object. Okay, so if I go to the cubes, oh man, I'm just going to open this one here. And I'm going to find the cubes here. I just don't like, there we go, test print folder. Extrusion multiplier cubes. Unlabeled. So it's just basically an unlabeled cube is what he's looking for here. But what am I looking for? The thing is, I can print this little flat cube. Let's see what he says we're looking for when we print the cube, because he talks about printing multiple cubes. Okay, let's go beyond the instructions on printing them. Okay, so here's what we're looking for. Gapping, lines just barely don't touch, almost perfect, ridges, and ridges. Okay, so if I print one cube at the existing extrusion multiplier, and I guess I can compare it versus having to, I mean, I could print 3 cubes, one on each side of the yeah, make 9 copies. 88, 90, 92, 94, 96 to start, but you can do 90 and 95 and see where to go from there. Yeah, I just don't want to take up a lot of time, because it takes a while to print a bunch of cubes. So let's go with what MG28 text is saying, and we'll do a 90 and a 95, and we'll go from there. So let's get the cubes. We'll get the ones that have 90 and 95 on them, and I think those are just for identifying purposes. I think the only difference here is that he's labeled the cubes so that you can you're not guessing which one you printed. So we can go 80 to 1.2. So we can go take a 90. Let's take a 91. Okay, yeah, and I believe they're just, yeah, it just means that they have the numbers written on them. Download the 90. Let's go back. Download the 95. I mean, you can get really technical, print all these cubes and get, it depends how fussy you want to get, right? Download the 95. And let's go back and let's download the 1.0. Ellis is doing it the hard way. Well, I think he's doing it the extremely precise way. Run Luke's 2-wall cube, then calculate the value from the wall measurements. Now, where's Luke's 2-wall cube? I could do that. In Super Slicer, you can, yes. I don't have the latest version of Super Slicer. So you're saying Luke's 2-wall cube. Basically setting up a template for filament extrusion multiplier testing. Yeah, exactly. Yeah. And Super Slicer. I don't have Super Slicer. You just dropped the Thingiverse link. Oh, it didn't come through. Let me just do it this way. We've got this here. There's so many suggestions. That's okay. Do I have Super Slicer? Let me see if I have Super Slicer still installed. Oh, I do have Super Slicer installed. Do I have a profile? Let's see if I have a profile for the Voron. Super Slicer error. Failed loading preset file. Whatever. We've downloaded a few test cubes. So Super Slicer doesn't want to. Let's try once more. Yeah, it's the definition of insanity. Yeah, I've got to... yeah, I need to reload. I need to re-download Super Slicer. Okay, and you all see that just rebooted again. Did what it was doing. So let's go ahead and just do. Let's just print a cube. Let's just get a cube printed. Let's take this off. This was one of the pressure advance. The old way to do it. I can use Prusa Slicer, but I can't set it. According to everybody, I cannot set separate extrusion multipliers in Prusa slicer. Come on, downloads. And where are the cubes I just downloaded? There we are, right there. Okay. Okay, so let's go ahead and open Prusa slicer. Let's do the 95 cube first. And I want to see, unless there is in the new Prusa slicer, and depending on the version I have. Look at Ellis's guide, misconceptions and bad advice section. Do I have to right now? Oh, I see. I just want to print a cube. I just want to print a cube and see how it looks right now. I'm going to print one at 0.95. I want to see what he says for the settings. 100% line width. Don't use percentage in Prusa slicer and Cura. Yeah, you must instead put an actual number in millimeters. Example, 0.4 with a 0.4 nozzle. Yeah, okay. 2 bottom layers, as many as you can fit, and still have at least 2 layers of infill. About 10 to 11 with 0.2 millimeter layer height. Okay. First layer height 0.2. Perimeters. How many layers did you say at the bottom? I'm move this out of the way. 2 bottom layers. As many as I can fit on the top. I don't want spiral vase mode, sorry. 10 or 11 it says. And have at least 2 layers of infill. Talking to me, not you, Tim. Oh, okay. Oh, okay. Jeez, okay. I've got to just focus on what I'm doing here. Top layers as many, so we'll do 10. Top infill pattern monotonic or lines and Cura. Okay, top infill pattern monotonic. But how many perimeters does he say? Bottom layers 2. Top layers monotonic infill. Okay, I gotta read a bit more here. He's not even talking about perimeters or infill percentage. Okay, you don't use these percentages and carry. Okay, instead put actual numbers. We've got that. Top or bottom line width set equal to your nozzle size. Okay, so we just 0.4. Okay. Line width. Yeah. Yes, absolutely, Delmar. Oh, now I got a dog whining upstairs. $2 and 20%. Yeah, where did you see that? I'm gonna believe you, but where the heck do you see it? 2 perimeters, 20% infill. Top infill. Monotonic. Okay, we're set at monotonic. Bottom layer, minimum shell thickness 0, or we'll override this. 0. Okay, we're good. A lot of this is just the standard settings. Okay, okay. Top infill pattern monotonic, okay. Solid infill speed. Your profile's normal value. Fair enough. Top infill speed. Low to moderate, 60 millimeters. Where's my top infill speed? 50 millimeters is fine. Okay. Keeping your low moderate. Okay. Minimum layer time 0. Prusa slicer. Slow down print if layer time is below. Slow down below layer time. Minimum layer time. Where's my minimum layer time? Advanced. Where do I find minimum layer time in Prusa Slicer? In filament settings, okay. Actually, the real quick way is to go that doesn't even, it's probably called something different. It's got to be called something different. Anyways, I'm going to change this anyways. 215. Under cooling. Really? Minimum print speed. It's got to be called something different in Prusa Slicer then. Let's see what else he has though. Moderate to high fan speed. It's already high for PLA. Slice the test cubes with variations 1 to 2. Okay, that's fine. We're going to do the extrusion multiplier in a second here. Okay. So we're doing the 0.95 right now. So the extrusion multiplier for the filament is going to be under right here. So right here, we're going to go 0.95. For the 0.95 cube. I'm in expert mode, yeah, and I can't find the minimum layer time. Minimum layer time 0. I'm guessing that's defaulting to that anyways, but yeah, it's got to be a different name. Yeah. And cooling. Minimum print speed. Slow down if layer print time is below 20. Enable fan if layer print time is below. Cooling thresholds. Okay. You don't think I rebooted the Pi? I probably didn't. Second from the bottom. Oh, slow down layer time if time is below. So I want that to be 0. Minimum layer time 0. because that's what he's asking. He says minimum layer time 0. Process / slow down print and layer print if time is below and AKA okay 0. I went right by it. Okay, let's save that setting again. The cubes, and I think we're okay. Print settings. That's the only ones we changed. Let's just get this. Let's just get this going. It's going to take 8 minutes. 8 minutes to run this cube. Oi. You're not going to find the potato. Yeah. Yeah, of course you had an issue finding it because I bet this stupid. I'll bet this is not. Anyways, let me make sure. Under printer settings, test. It works correctly. 178. I know it says Octoprint, but there's no clipper in here. It's always been Octoprint. Okay, let's go ahead and see if it's working now. Yeah, of course you're not working. Oh, it did. It worked. Yeah, so obviously the thing was rebooting. No, I guess I didn't reboot the Pi yet. Okay, let's go ahead and print that. Let's get it going. Oh, man. I'll have to reboot the Pi, but I got to try and figure out that little, that dropping issue. It's annoying. It takes 8 minutes to run. Like Luke's cube. Okay. I want to run this, and then I just want to run one of these cubes. I'm going to have to work a little bit on extrusion multiplier. And of course, yeah, that's going to probably vary per filament too. It worked fine for you. Okay, yeah, and it might work. I just probably didn't reboot the Pi yet. You're correct. I restarted Clipper, but I did not reboot the Pi. You're correct. We'll reboot the Pi when this long print we're doing right now is done. Oh, you know what really helps too? When you're going to go do a print, this would help. There. That'll work better. And look, I have a souvenir to hang on my wall. Or, I am a general now. That is really cool looking too. That'd be a great bookmark. Sew it on my sleeve. General Filament here. Very cool. Fan speed 0.5. It will power those fans. Yeah, they're loud, aren't they? Controller fan section. Let me go there now while I'm thinking of it. I think they are LCD screen. Oh. I don't know what that was. That might have been when I did the update, the main sale update. We're printing though. We are heating. Let me make sure. Yeah, we're heating the bed. The bed's warm, and now we're heating the nozzle. Let me make sure. Let me confirm with the dashboard. Yeah, bed's at 60. We're heating the nozzle to pre-printing temperature. Okay, let's go to that fan section. Printer config. Yep. And we've stalled again. We've stalled again. But the printer's going. That's the main thing. My live streams never go as planned. I was supposed to get all this tuning done and get another cube printed all in the span of 3 hours. But no. Murphy had his own plans. Okay, printer config section. We are going to look for the controller fan. Where's my fans? Fan. Controller fan. Kickstart time 0.5. So add fan speed 0.5. Yeah, let's do that because those are loud at full speed. There we go. Fan speed 0.5. Save and close. Let's see what happens. Look at the lag. Look. Oh, my picture's in the way. Anyways, doesn't matter. Now it saved it. Now it saved it. Let's turn the camera here. Let's go to this guy. There we go. We are doing our Z calibrate. We just get this cube printed at 0.95 pressure advance, or 0.95 extrusion multiplier, and see how it looks. I'll do the full. I'll actually do the full. I'll download Super Slicer. I'll do the full test. I'll print a whole bunch of cubes off stream so that I can have a look at them and pick an actual one. But this, you know, that's a fair bit. Let's see. Okay. Mesh. You're about to spend coin on Noctura fans. Yeah. I have. Actually, I have. Well, this is doing its thing. Let me go have a look. I have a bunch of those fans. I don't know if they'll work for this. Let's see. Don't ask me why. Oh. Don't ask me why. I know you're going to say, why? But I have. These are all Noctua fans. So, I've had these for a long time. I have a 4x10, two 4x10s, two 6x25s, and a 9x14. So the 9x14 is massive. It's big. That might actually be a good replacement for that bamboo auxiliary fan that's stupid loud. The 6x25s, they may work for these bottom fans here. This may be the one. That's the 6x25s, and then the 4x10s are actually quite small ones. So, you know, it's probably about time I put the, I don't know why I have these. I'll be honest. It's been 3 years or more. But it's probably about time I put these to use. I'm going to see if they'll fit there, actually. These 6x25s might just be the good replacement for these. Ellis's examples look a tad over extruded, but no gaps in the walls is good. Yeah. So yeah, and then this one, this might be good for my P1P bamboo, that massive fan on the side. I am gonna, yes. Who suggested that? Who? Oh, Diabolicillin. Diabolicillin. You're new here too. Welcome, and you're a Canadian. Look at that. Hope everybody here is subscribed. Down over here. Subscribe. I have a fun channel. Everybody will tell you that. It's fun. I don't always know what I'm doing, but I eventually get my way to doing what needs to be done. Oh, here we go. Here, it's printing. Look, ready? And poof. It's printing. It seemed like a good idea when I bought. I'll bet you I paid a whole lot less for these fans than you would pay for them today. I don't know what fans are worth these days. I don't even remember why I got these, but yeah, that I'm gonna, wow. This big sucker, let me open it. This would probably be a good replacement for that bamboo. Oh yeah. Let's have a look. Come on, get out. Yeah, that's big. Look at that. Oops, look at that. There is no Z. Let's see what this looks like. Where's the bamboo? That might work. I'm going to have to look into that. That might just work. Okay. And they come with all the connectors you could want. Did I bump the camera? I have a habit of doing that. Okay, and let's look at these other ones. Yeah, these. What's going on here? These ones. Let's open this and see. Oh yeah, that I think would be a drop-in replacement easily. So this guy here, yeah, that would be a perfect replacement for these. Fortunately, I only have 2 of them. Yeah, because these are, what are they, 12 volt or 24? They're 12 volt. I don't know if these are 12 or 24. Doesn't matter, I can still use them. Yeah. Okay, well, that's, I'm glad that you reminded me that I had these things. Okay, well, good. What are you doing, Filament, over there? Oh, you're just, oh, you're tightly wound, that's why. Okay. Mr. Noctua to the rescue. Hey, there's more content too. Look at that. some fan replacements coming up. 12 volt or 5 volt usually. Don't forget to set the fan voltage on your MCU to 12 volt. Yes, yes. I think these are 24. No, they're not going to be 24. These won't be 24 volt fans that are on there now. Anyways, doesn't matter. I'll figure it out. So keep reminding me of stuff that I forget that I have. $24? Yeah, I'm thinking these might be 24, but it's easy enough. I can just plug them in and change the jumper on the board to 24. LDO fans are 24. Okay. Although, you know, I'm not. They don't bother me except when I'm streaming and they're loud right next to the microphone. But I'm definitely going to try that one in the bamboo. Yes, yes, yes. No, might not work on that because the bamboo one's a directional fan. It's one of those, you know what I mean? Yeah. Yeah. %. And we'll see how it looks. PWM. PWM, that's what they're called, yes. Yeah, it's the one that blows like it's like the park cooling fan on this. It's like the fan that's up here on this. PWM, it's like a directional fan. I think we're on the last couple layers. We're on layer 15 of 15. We are done. Okay. So this is 0.95. Like, holy cow. Okay. Extrusion multiplier of 0.95. Just getting this camera set up so it's not so bouncy when I turn it. We'll give this camera here. Look at that. See what I see? Look, I see that. And I see that and all the chat. Come on, focus. I know you can. I know you wanna. There you go. There we go. It's not bad. I don't know how my corners look. Let's pop it off here. Let's make sure my bottom is good. So there we go. That's his labeled one. So 0.95. The bottom layers actually could use a little more squish, but corners. Come on, stop not focusing. Does it feel smooth? It feels smooth as a baby's bottom. Like, yeah. That's not bad, and it's very smooth. Like, yeah. Did I check for at least 2 layers? Oh, no, I didn't. Oh, wow. I didn't. I just took its word for it that 10 layers would be good. You watch. Oh, geez. Come on, have some infill. Oh, yeah, there we go. So there's one. Oh, we're going to consider that infill right there. Yeah, that's infill. Theoretically, there's 1, 2, 3 layers of infill. Too low. The infill's too low. Oh, come on. Come on. Really? Really? I can't do that again. But we'll continue this. But I mean, heck, it's good. I want to run a cube though. Yeah, we're going to play with the extrusion multiplier a bit more. And what else does he? What comes after extrusion multiplier? PA and pressure advanced extrusion multiplier oddities, cooling and layer times, retraction, infill perimeter overlap. I mean, he gets into detail. Holy crap. So I just want it to print a good looking cube to begin with. Then we'll worry about all that. Yeah, the bottom layer on this could be a little bit closer. I probably could have stepped that down a little bit, but yeah, because if we check that out, actually, it's kind of hard to see in that camera, but that top is pretty good. Yeah, I know. I got to get those lines tighter. That needs to be closer to the bed. And I think what could have happened there, in all honesty, and I didn't check it because I was having that let's see, I got drip. So what happens on this, because of the way that the nozzle, the way the Z calibration works on this, is if there's a little bit of filament on that nozzle that's hardened, it's going to affect that offset. So if there was a tiny little bit of filament on the nozzle when it was doing my Z calibration, and that just that tiny little bit of filament would have said, okay, the nozzle's a little bit closer to the bed than we think, so it would have raised that Z offset a little bit, enough to cause this. But if you look at these cubes that I did, when I know that when I know for a fact that this one, first layers were good. If you look at those first layers, great. I know you can focus this close. Oh, come on, camera. Do it for me. There we go. If you look at these, I wonder if it might actually just show up better on this camera. These first layers turned out really nice. See, that's the kind of first layers that we were getting. So and that one and on this one here. So I'm suspecting that what happened on this one is that there was a tiny little bit of filament hardened left on that nozzle when it did its probing for the Z offset, or for the Z calibration. That's why you don't like nozzle probes. There you go. Yeah. Yeah. But something funky happened here because I was heating up. It's to do with this dripping or the dropping. Let me home this thing now. No, hang on. See, this is all pausing again. See, I got hardened filament on there now. So technically what's going to happen is the nozzle only heats up to 70% of printing temperature to do the probing. And that should prevent any ooze. I love, like, for instance, on the Bamboo P1P, it does a thorough nozzle wipe before it does it. Now, what I need to do is put a nozzle wipe on this so that we do a nozzle wipe and then we do our probing. So yeah. Seems to need a bit more pressure advance to get the corner straight. That's a possibility too. I mean, I'll rerun these tests as well, but the basic premise of this is to understand why you're running the tests. So depending on what I'm printing, these corners might be fine. But if I'm printing, actually, I should measure this cube, measure this as well. I think this should be what? Higher extrusion multiplier, you get a bit more squish on the first layer too. Yeah. You know, extrusion multiplier 1 might be fine for this filament. And I've got, these are 30 millimeter cubes. We're measuring in at 2994 and 2981. No, sorry, 2981, 2986. So we are, I mean, that's a whole other ballgame worrying about the size of the cube, but it's pretty much square. And then as far as thickness goes, we are 3.1 millimeters thick, and I think it was supposed to be a 3 millimeter cube. 3 millimeter thick cube. Your ooze is above 170. PETG ooze is just a bit hotter. Yeah, I can adjust in the config. I can adjust down to whatever percentage of the final printing temperature I want it to do. I'm gonna restart that Pi because it's still doing its dropping thing on and off. So let's restart the Pi. Let's reboot. Let's go ahead and reboot the Pi. And we'll keep an eye on it for the next couple of minutes while I close out and see if it does the reboot. But I'm going to, when I finish the stream, I'm going to reprint another one of these cubes in the same filament, same color as this one. And we'll see if it's looking any better with the changes we've made with the input shaper, pressure advance, and we'll run it at I think I'll go to 0.98 extrusion multiplier and see what happens. And we'll compare the cube. We'll compare the two cubes next time we get together. So, yeah. There we are. Look at that. The color's a little richer or deeper on this camera. I got to adjust this camera a little bit more. I still got to play with where I want to place these things too. So, extrusion multipliers mid 90s with step set for 100 millimeter feed. Based on Ellis's, you're under. Okay, we've rebooted. The Pi is rebooted. Let's get rid of some of these scraps. Of course, cannot update the MCU config as it shut down. Oh, okay. Let's firmware restart on this. That's right. And system, there we go. And there we go. Okay, we're booted up again. Let's really quick, let's keep an eye. Let's go ahead and get this cube started. Let's download this cube again. Let's slice it. And while we're doing that, I'm going to keep an eye on this screen and make sure if we're getting that dropping happening again. That's just really, really strange and annoying that happens. Okay, let me find my cube. Where is it should be on my desktop. It should be called a Voron Design Cube. There we are. Okay, and I always, I'm slicing this cube up. So there we go. We will use I'll use the standard like I do for the parts. I'm using 4 perimeters, 5 top, 5 bottom. I'm using 40% infill with, I like gyroid on these infills, that's fine. And I am going to use filament settings, same temperatures. We're going to move the extrusion multiplier. Where did I find it? Oh, let's put this back up to 20 where it was. And the extrusion multiplier to 0.98. Help that bottom layer just a little bit. Hey, no problem. The filament we are running right now is a filament called Grat Kit. It is right here. It's filament they sent me to try. Oh, and it's unspooling here, which does not help. That would cause me an issue. There we go. Company called Grat Kit. Oh, let's go this way. There we go. And it's just Grat Kit PLA. Great. Why are you? Oh, because this is coming through way too much. There we go. Okay, you are just annoying. Oh, this is twisted. That's why. Come on. There we go. That's better. That'll work. Okay. Let's go ahead and slice this cube now. And we're not going to stream the whole printing of the cube because it's going to take 1 hour to run the cube. We will send it over. And it is there. And we will go like this and we will print it and we'll see how that works. But there we go. This is it. So we're going to let that print. We'll compare it next time. And we will continue tuning from there. I will read through this Ellis guide a little more, see if there's anything else I want to do and stream as far as the tuning goes. But we'll compare the quality of the two cubes. This was done pre-tuning anything. The only thing that was tuned for this cube was the hot end, the E-steps, basically. The extruder was calibrated. That's all that was tuned on this. And this had some ghosting on it. It had some ringing. It had fat corners. So yeah, we'll see what happens. Anyways, that's it for tonight. Thank you everybody who's here and who's hung out, and everybody. I appreciate that, and we will catch everybody on the next stream next Sunday, 5 p.m. Mountain Standard Time. Until then, we'll see you guys. You guys have a great week. Stay safe and stay happy and keep printing. Bye for now.